All right, section 2.5, we're going to take what we learned from long division and we're going to apply it to how do you find the zeros for a polynomial function. So what that means is where does that polynomial function cross the x-axis? So if I have a cubic equation, maybe it looks like this. It's got other stuff added on there. So what are these points where this polynomial's crossing the x-axis? So that's what we are going to use the synthetic division that we worked on yesterday to find. A couple of things though before we do that. If you look at this first theorem that we have, fundamental theorem of algebra. Fundamental theorem of algebra we kind of talked about already. It just tells you whatever the highest degree for the polynomial function is, that's how many zeros you're going to have. And by zeros, we're talking about places where it crosses the x-axis, but you might also have imaginary roots, or you might have real roots. Doesn't mean they have to be nice round numbers. They might not be integer values. They might be decimals. They might be irrational numbers where you have square roots. They could be imaginary numbers. So it just tells you how many total roots you're going to have. So if you look at this first example here, how many roots you're going to have? Well, if you look at the terms for the polynomial, the largest degree here is degree 5, so we're going to have 5 roots, or solutions. And again, they could be real numbers where you can see the places where they touch the x-axis, or they might be imaginary roots which don't cross the x-axis. And we'll look at how you find all of those in a little bit. For the next one, the power or the degree is 4, so you're going to have 4 roots or solutions for this polynomial. Okay, we're going to skip the next part on linear factorization. I'll kind of talk about that as it happens. Let's go on to the next page. This complex conjugate zeros. So that's just a fancy way, and we'll get back to this again in the next day or so. But this theorem here tells us that if you have a root that's 1 minus 2i, then its conjugate is also going to have to be a root, which means 1 plus 2i would have to be a root. If you had negative I as a root, then positive I would also have to be one of your roots. The same holds true for irrational numbers. So if I had 1 plus root 3 as a root, 1 minus root 3 as a root. These are all called conjugates. And they all come in pairs like that. So this is a pair. So the conjugate, you just change the symbol in between the two terms there. Nothing else gets changed. So 1 minus 2i, you just change the minus to a plus, and that's the conjugate for it. So these roots come in pairs that way. That doesn't hold true for rational numbers. So like if 1 is a root, it does not mean that negative 1 necessarily has to be a root. So they don't come in conjugate pairs. Just imaginary numbers and irrational numbers, square roots. All right, now we're going to look at some examples of solving for all the roots. So to solve for all the roots, we are not going to do the examples that are listed here today. So you're going to need to put this somewhere else, somewhere where you can find some space to write. And I'm going to fire up my calculator here to put this, use my calculator. So some of the things that we're going to go through to do to find these roots, the first thing we're going to do is we're going to find one of the roots or one of the solutions using your calculator. So in your calculator, hit your y equals, look up here, make sure the plots are not turned on. If they're turned on, we need to turn them off. That means your calculator wants to do a scatter plot, and we're not doing scatter plots. So we'll put the first equation in the calculator, and I'll write it down on the next page. Since I'm here, I'm just going to put it in here. So let's do this one, x cubed and plus 4x squared, and then plus x minus 6. All right, so this is the polynomial. I'm going to slide this over here, that we're going to find all of the roots or solutions for. So as you go through and you solve these problems, what I suggest that you do, I'm just going to move this thing out of the way here. So this is what I would suggest that you go through and do. This is how you're going to solve these for me. So the first thing I want you to do is graph it in your calculator. Right, so we're going to look at it. Once we've looked at the polynomial, we're going to use the zero function in the calculator. Get one rational zero. That's a nice value there that you're looking at. A nice integer value, positive or negative, or a terminating decimal, might be a repeating decimal. So if you get 0.33333, 1/3 is a factor or a root. If you get 0.5, that means 1/2 is one of the zeros. You'll probably try to use positive or negative whole numbers instead. So once you get that, once we find one, we're going to use that root or that zero that you just found in number 2 to divide, and you'll use synthetic division. And then once you've used your synthetic division, you'll end up with a polynomial either by factoring or quadratic formula. So the problems that you have for today, for tonight's worksheet, will all be able to be factored. If you don't like to factor, you want to do quadratic formula, do quadratic formula. It doesn't really matter to me, but you need to be able to solve them. So if I look at this first problem, then I have it in my calculator, I'm just going to hit zoom and 6. That'll reset my window in case I have something weird going on with my window from the scatter plots. So I'm looking at this graph, and it looks like it crosses right here at, no, it doesn't want to write, that's okay. Looks like it crosses at -2 and -3 and +1. So if you look at that, oh, there we go, now it came up. So if you're looking at these values, it looks like -3, -2, and +1. Just need one of those values. So I want to go into my calculator, and I want to find out, because it may not be, it looks like it crosses at 1, but maybe it's 1.01 or something like that. So let's use the zero function on the calculator to find one of these 3 zeros. Whichever one you want to find doesn't really matter. So second, and the calculate button, we want a 0, which is number 2. Left bound, right bound. So let's pick one of these to find. Let's try that 1 that's over here. So my cursor needs to be on the left side of 1, needs to be on the right side of 1. Hit enter. You don't want to guess, hit enter. And then if you look, the 0 comes up. X is 1 when Y is 0. So that's one of my zeros. I could have done any one of the 3 zeros that you see there. That's the one that I picked. So using my calculator, I found out X equals 1 is a root. So I'm going to use synthetic division. 1, the value that we just found with the calculator, is going to be the number that goes in the box. The coefficients for my polynomial go across the top row, just like we did yesterday. Bring that first term down. You're going to multiply 1 times the 1 in the box, which gives you 1, and then add down, and we get 4 and 1 is 5. Multiply 5 times the 1, we get 5, and add those two together, we get 6. And the last one, 6 times the 1 is 6. Add down, you get 0. Now you should get 0 because we looked on the calculator and found out that this thing was a root. So if you come up with a remainder, you screwed something up. So now what I can do is I can take these terms, remember this are the coefficients for the depressed polynomial. You start it with a cubic equation, so these are the coefficients for a quadratic. And if I set that equal to 0, I can find all the rest of the roots. Like I said, these are all going to factor for you. So this factors nicely however you decide to factor. I don't do that British method thing. X times x will give me x squared. Plus and a plus is a plus and a plus in here. Factors of 6 that add up to 5 would be 2 and 3. 2 times 3 will give me 6. 2x plus 3x will give me 5x. If I set each of these factors solutions were 1, and then -2, and -3. Right, so that's the process. Find one of them with the calculator, find the other 2 used in factoring your synthetic division. I'm going to tell you that you have to do this. You have to show this, because tomorrow we're going to have polynomials that will have imaginary roots or irrational roots. You're not going to be able to just get them from the calculator. This you could do all in your calculator. Tomorrow you won't be able to. So let's do the easier problems this way, and then this way. Tomorrow when you have to do the harder ones, you'll be able to do it without your calculator. All right, so if you need to pause the video to write any of this stuff down, pause it. Otherwise, I'm going to erase this, and we're going to go on and do another problem similar to this one. All right, so it's going away. All right, so let's do another one that's similar to that there. Let's do this one. All right, it'll be the same process. So let's see, let's do 2x cubed plus 3x squared minus 3x minus 2. All right, so we'll put this in the calculator. We'll come up with one of the roots. Right, 2x cubed plus 3x squared minus 3x minus 2. I think I got all in there right. Just graph it. Find one of the roots that you want to work with. So it looks like it crosses at -2, and then somewhere, I don't know, maybe -1/2, looks like +1. Let's use -2 this time since we used 1 the other time. So let's just be sure that it actually is a root. So second and calculate. We're looking for a 0, left bound, right bound. So move it cursor so it's left of that green blob. Somewhere to the right of that green blob. And then there it is on the green blob. -2 is actually a root. So that's the one that I'm going to start with. And again, you can pick any of them. That's the one I happen to choose. So x equals -2 is a root. So that's the number that's going in my box. Coefficients for my polynomial along the top row. Bring the first term down. Multiply, add down, multiply, add down, multiply, add down. Again, you should get a remainder of 0 because we just used the calculator to come up with those roots. Coefficients for my depressed polynomial, 2x squared minus x minus 1. Set that equal to 0. Now, like we said, that should factor for you because all of the problems I gave you tonight have rational roots. So I need factors of 1, which are 1 and 1. It's going to be a minus there and a plus there. So -2x plus 1x will give you -x. Set each factor equal to 0. So x is 1. This would give me 2x is -1, so x is -1/2. So let me get rid of this thing. So for this one, my roots are the -2 that I started with, the -1/2 that I found by factoring, and 1. Now there's another way that you can write these answers, and I usually don't do this. It's called linear factorization. It's just basically writing this in factored form. So if x equals 1 is a root or a solution, x minus 1 is the factor. X equals 1/2 is the root, 2x plus 1 was the factor. And then back here, x equals -2, so x plus 2 is the factor. So if you see that terminology, linear factorization, that's the way they want you to write it. Instead of as the answer, they want it in the factored form there. I probably wouldn't ask you to do that on a test. Okay. You can either start the homework, or I'll do one more example if you feel like you need one more to look at. Same idea here. So let's try this one then. cubed, 2x squared minus 2. All right, so this one, again, if we put it in the calculator and find the zeros, let's see, x cubed, trying to cheat here, plus 2x squared minus x, and then minus 2. Okay, I think I got it in there. Right, again, looking for the zeros there. We could use any one of these three here. Looks like it crosses at -2, -1, and +1. We can find one of those zeros. You probably will try and check that x is 1, 0 most often. And 1 is a 0, so we'll use that factor. Let's see. Just think about it. If you're going to multiply by a number, the number in the box, if it's a 1, it's easy to multiply by. All the coefficients for that polynomial across my top row here. Bring the first term down. Multiply and add. Multiply and add. Multiply and add. Coefficients for depressed polynomial, we start with cubic, so this is quadratic. Set it equal to 0. And then again, all of these tonight will factor. So if I set each of those factors equal to 0, I get x is -2, x is -1. So my roots, again, it was a cubic, so I should have 3 roots. Here's the first one is 1, and then also -1 and -2. In that linear factorization form, x equals 1 is the solution or the root, so x minus 1 is the factor. -1 is the root or the solution, so x plus 1 is the factor. -2 is the root, so x plus 2 is the factor. All right, really, this is how I want to see the answers, but I want you to see that linear factorization form. All right, so now you have a worksheet that you can go through and do. 10 problems on it. All of the problems in the homework all will factor in this second step. They'll all have a nice rational root to start with. I want to see the synthetic division. I want to see the factoring. I don't want to just see 3 answers. I know you can put them in your calculator and come up with them. Okay?